Okay, these are the last of your problems that you'll be doing for your daily work. We're going to show that f composed with g of x equals g composed with f of x equals x. If it does, it means they're inverses of each other, and we'll talk about that in section 4.2. For today's lesson, though, all we're doing is showing that they work, and I will do the odds, and you'll do the evens in class. Okay. So the first one I gave you for 45 is f of x equals 2 of x and g of x equals 1/2 x. So for this to work, you have to show both ways. You have to show f composed with g of x, and that's Boolean algebra for and, g of f of x has to equal x. Both of these have to equal x. So I have to do both ways. I'm going to do f composed with g of x, which is what? 1/2 x. So I write down f, which is 2. I put parentheses, and I'm going to dump in that 1/2 x. And when you multiply that through, you get x. So that's a check. And now we're going to do g composed with f of x. So that is g composed with 2x. So we write down g is 1/2 x, and we dump in 2 of x, multiply that across, and that equals x. That checks. So these are inverses. Alright, next. Same thing here. We're going to compose f with g of x. So we're going to compose f with the cube root of x, which equals f is x cubed, and we're just going to put this inside, which is cube root of x. And we'll get into this a little more, but you should know the cube root, you can write the rational way of writing cube root of x as x to the 1/3. So this is the equivalent way of writing that cubed equals x to the first, which is just x. So that checks. Then we're going to do g composed with f of x. So f of x is x cubed. I'm going to write down g. G is cube root of x. So instead of x here, I'm putting x cubed. So basically this is x cubed to the 1/3, which equals x, and that checks. So they're inverses. The next one, by the way, if you've gotten this far and you're watching the video, this is the kind on your test, right here. So basically we're going to do the same thing we did before, f composed with g of x, which is basically f, and g of x is that, so that's 1/2 x plus 6. So I write down f, which is 2, and everywhere there's an x I put parentheses. And I'm going to dump in this. So this is 1/2 x plus 6. Now, when I multiply this, these 2 times 1/2 is just 1. And since this is a multiplying thing, you're just going to get x plus 6 minus 6 equals x. So that works. And now we're going to go the other way and do g composed with f of x. So that's g, and f of x is 2x minus 6. So I'm going to write down g. G is 1/2. And for the x, I'm going to put parentheses plus 6. And what I put in this parentheses is 2x minus 6. And then I just kind of use my PEMDAS tricks. I know this I can combine, and I'll just get 1/2 of 2x, because negative 6 plus 6 is 0. And 1/2 of 2x is just x. So that checks. So basically know how to do this kind on your unit exam. And for 51, basically what I did on your different versions is I just made different numbers here. Right? So we're going to use, we're going to compose f with g of x. That's f with g of x is 1 over a, x minus b. Now remember, a can't be 0. They have to state this because you can't divide by 0. So I'm going to write down my f, which is ax, but for the x I'm going to put parentheses, plus b. And I'm going to dump in g of x, which is 1 over a, x minus b. Again, this equals 1, so you're just going to get x minus b plus b. That equals x. And then for g, composed with f of x, I'm going to use, write down g. My f of x is ax plus b. And then I'm going to write down g. And g is 1 over a. But everywhere there's an x, put parentheses. I'm going to input ax plus b. I'm going to clean this up, and I get ax because basically I could erase this parentheses here, and b minus b is 0, so that just equals x. And that is all.